about the vector database. Understanding about the vector database. This is the prerequisite. I'm hoping that you went through the last session, right? So these complete sessions are analogous to each other, right? So that's why focus. Right? It's available on YouTube, guys, right? So you can watch it anytime, right? Now the concern here is, guys, because of the time bound, we're not able to finish the entire things in a single shot, right? So it will be near about 6 to 7 hours of the workshop, right? So that's the reason that we have divided into the parts, right? So today we are going to discuss about the second parts, right? So before moving into the second parts and before discussing the today's agenda related to this workshop, right? So let me quickly recap what exactly we have seen in the previous cases, right? Okay. So first we'll talk about the vector databases. First we discuss about the vector databases, right? Right. And we got to know that what exactly there in the vector databases. So usually a vector databases are designed. Right. Don't worry, guys. This is not a theory session today, right? Because the main thing is we'll focus on the implementation part, right? But guys, remember one thing: if you don't know the internal things, what's the use of simply implementing the things, right? Because there is no value for the direct implementation if you don't know the inside, if you don't know the internal, right? So you have to understand the both aspect. You have to understand the engineering aspect as well as you need to understand the science aspect. Then only there is a value for the implementation, right? Otherwise, simply using a lang chain and implementing the lag pipeline, it is not at all going to help you guys, because nowadays the competition will be at the next level, right? So that's the reason I'm telling that you have to know the both aspects, engineering aspects, as well as you have to know the science aspect. Then only you will understand where to use which strategy. That is the most important thing in the today's world, right? Okay. So anyway, so vector database are nothing but a vector database are designed to store a vector, stores a vector. And we know that how exactly we are storing a vectors, guys, right? We discuss about the how the text is getting converted into the vectors. We talk about the cosine similarity and all these things, right? And also we are searching and search a embedding vectors. This is the usual thing that will be there in the vector databases. So usually vector databases are designed to store the vector and search a particular embedding vectors, right? This is the entire goal of the vector databases here, correct? Now guys, we also discussed that what is the difference between the traditional databases, right, and the vector databases, right? So whenever if I'm talking about the traditional database set, you are exactly doing a search on the basis of keyword, right? Suppose you wanted to search a particular things in the database, you are writing a proper SQL query with a specified keyword. But in the case of vector databases, you are not accessing a particular vectors with the help of any kind of exact keywords, right? So we are trying to get a relevant vector which is semantically similar to our query points, like that, correct? So the advantage of the vector databases, right? We discuss about the advantage of the vector databases, right? So guys, vector search obviously a fast search, right, compared to the other advantage of the vector databases are the vector search. Vector search is always a faster, always a fast, right? That is the most beautiful advantage of the vector database. It is always a faster. Vector search is always a faster, right? What conceptual meaning, right? Okay. Now the second thing is what, guys? Here the second advantage of the vector databases is what? So usually, guys, if I wanted to build any AI powered application, right? Suppose I wanted to build any AI powered application. If I'm talking about the AI powered application, AI powered application means definitely we are using a LLM. Using a LLM. Okay, have you heard about this term, guys, called LLM? I hope everyone know, even small kid also know. Right? What is LLM? LLM stands for large language model. Right? LLM stands for large language. You can say that it's a AI system which understand the natural language and it is giving you the response back in your natural language itself. Right? So that is the kind of a thing. Whenever you are using a chat GPT, right? Whenever you are using a chat GPT, whenever you are using a deep seek, means definitely you are using a LLM. Right? Definitely you are using a LLM. Okay. So whenever you are building any AI powered application, means definitely you are using a LLM in your application. Definitely in that case, we required a vector databases case, right? So we required a vector databases here. This is the common thing nowadays, right? That we required a vector databases whenever you are building any AI powered application. Okay. Uh, Third thing, guys, if you talk about, I'm not talking anything here about the structural kind of a data, right? I'm talking here about the unstructural kind of a data, right? So if you are having a data in the form of text, data in the form of images, right? Or if you are having a data in the form of audios, right? So vector databases will work very good in that case, right? Because anyway, end of the day, whether it is a text, whether it is an image, whether it is a audio, everything we can easily convert it into the numbers, right? So you can easily convert this thing into the vectors, right? So for this kind of unstructured data, vector DB will work good. Vector database will work good. Good. There are many advantages, even though vector databases are having a RAG support. We are going to discuss today RAG, guys. है ना? Definitely, we're going to discuss about the RAG pipeline as well. Right? So vector database is having the RAG support. There's a one more thing, guys. You usually get a scalability factor in the vector databases. It's easy to scale, right? Although we required a concept of a software engineering here, definitely, right? Like a concept of database sharding, right? Like a concept of database sharding, right? See, guys, I'm not going to discuss any concept here of the database sharding, but usually in the classes, definitely, I usually discuss what is database sharding and how exactly we are going to scale your vector database by using the concept of sharding, partitioning, all this kind of a thing, right? But here we are having a limited amount of time, so that's the reason we can't discuss everything, right? Fine. But obviously, guys, you'll get a very high level overview exactly what exactly the RAG is and how exactly the vector databases are getting work. Right. So I'm not going to talk about the scalability, but for better understanding, because remember one thing is nowadays, because everybody is focusing on the RAG, most of the companies, the interviews are happening related to the RAG. So it's not about to understand only the RAG pipeline and you will get selected, guys, right? Because RAG is completely behave differently in the production, right? So you don't have to only know how what is the RAG pipeline. That is not enough knowledge nowadays, right? So you have to know many things particularly related to the RAG, like a different kinds of a retrieval, like a structural retrieval, right? You have to arrange the RAG pipeline also in the sum of the problem statements, right? If you are thinking that, okay, if you are having a too huge amount of a document data, right, that you will not able to scale it. So definitely you have to use this kind of a concept like a database sharding and all this thing. You have one more content management technique like Notion, right? This kind of a thing usually comes under the scalability thing, guys, right? Whenever you are taking your rack system into the production, right? That kind of a thing usually will be there, right? But guys, we are not touching this part here, right? Definitely we'll touch the scalability part in the class, right? Because I'm keeping this session very simple because I'm assuming that you people are the fresher. right? And you don't know anything, right? So that's the reason I'm keeping it very simple so that everybody should able to understand. So I will not involve any software development concept particularly in the context of this. But again, guys, end of the day, if you're looking for a Gen AI agentic job, I'm frankly telling this will be a 80% software developer job only, right? Okay. Anyway, okay. So let's talk about the things, guys, and we discuss about the vector databases, and these are the advantages of the vector databases. Correct. So I hope you got a somewhat clarity. What is the difference between the traditional databases and what is the difference between the vector databases, right? If I wanted to differentiate in a simple word, so let's talk about the traditional. Let me give you traditional DB, right? And let's talk about the vector DB. Correct. So in a traditional database, we will do a search basis on the exact keyword. You will have an exact keyword search, right? But in the case of vector databases, you are searching on the basis of semantic meaning. Searching, searching on the basis of semantic meaning. Correct. This is the first difference. If you talk about the second one, suppose guys, if I wanted to search anything in the vector databases, usually we are writing a SQL query. Right? We are writing a SQL query here. Right? And I discussed here about how exactly you will retrieve a data from the vector databases in the last session. That you are using a similarity search. You are using a similarity search. Correct? That we are trying to apply a cosine similarity and we are trying to find out the most relevant vector which is somewhat semantically similar to your query vectors. Okay. Third difference, suppose I wanted to talk about the, see, traditional database mostly related to the structured data, right? But vector databases are very famous in the context of unstructured data, right? Yeah. Next thing guys, we already talked lots about how to make a vector search very efficient, where we discuss about the k nearest neighbors, we discuss about the k means variation, which is a Lloyd's algorithm, we discuss about the KT tree, we discuss about the locality sensitive hashing, we discuss about the HNSW, right? These are the kinds of algorithm that we have seen how to make a vector search faster. But if you talk about the traditional databases, you are having an indexing, guys, where we are using a B tree, B plus tree, this kind of a thing. We call it as the multi-level indexing to make a particular, to search a particular records in a faster way. Here, guys, we are using a, here also we are having a faster searching with the help of algorithm like approximate nearest neighbor, right? Like a HNSW, right? Right? You are having a IVF, right? Many algorithms that particularly you have to make a vector database, vector search very fast, right? And if you talk about the traditional databases, guys, traditional databases are very good for your transactions, for a transaction, right? Generally, guys, if you talk about the SQL, MySQL, MS SQL Server, Oracle, these are all the transactional databases, right? So we are usually using the databases for the daily transactions, right? I hope you know the concept of OLTP and OLAP, right? So these are all comes under the OLTP, right? So whatever the database that you have used till now, which is a MySQL, Oracle, MS SQL Server, right? These are all the your transactional databases. But vector databases, guys, are very good in the context of AI, right? So it's a best for AI and semantic search. This is the general difference between the traditional databases and vector databases. I hope guys you got some sort of idea. This is we have seen in the previous sessions, right? So you can say that I have wrapped up this session in 5 minutes, right? Whatever we have seen in the previous cases, right? So those who wanted to know that how and what are the different algorithms that we are going to use to make a vector search faster, just go to the previous sessions, guys, right? You will understand the things in a better way. Okay. I hope, guys, up to here, everything is clear. No doubt. If you have any kind of a doubt, I will give you 1 minute, guys. And if you have doubts, please ask, right? Before I'm giving the today's agenda, right? Please ask, guys, if you have any kind of a doubt. No doubt means I will go ahead, right? Is that fine? Shall I go ahead, guys? So today we are going to discuss about need of RAG. Right? First thing. Second thing, we'll see a RAG scenarios. Correct. Third thing, let me discuss about the RAG pipeline. Right. Fourth thing, let me discuss about the basic things about the embedding, basic embedding. And finally, we'll do a lang chain and implementation. Right? These are the today's agenda that we already discussed about the vector databases, right? Now it's a good to start and good to discuss about the RAG, right? See, guys, this session will be both. You can expect a good amount of a theory as well as we are having an implementation, because without explaining the things, it's harder to implement the things, right? So there's a reason that we'll discuss about the RAG. We'll discuss about the RAG scenario, in which context that you are going to use this kind of a thing. We'll discuss about the rack pipeline. I will not go too much detail because again it will take, see guys, usually in the class, a RAG itself will take 2 weeks, right? Only to explain a RAG and vector databases, right? So that's the reason, because of the time constraint, we are understanding the things in very high level, right? But hopefully you will understand what exactly the things are there in the RAG, correct? Okay. Okay. So let me start with the first thing, which is a need of the RAG. Okay. Right. So everyone know, guys, what is RAG? RAG is nothing but retrieval augmented generation. Right. RAG is nothing but the retrieval augmented generation. Correct. So this is the concept called retrieval augmented generation. Nahi pata hai, guys? So you got to know now. RAG stands for retrieval augmented generation. Okay. So just now we discussed about the LLM. LLM is nothing but the large language model. And I already told that whenever you are using a chat GPT, whenever you are using a DeepSeek, right? So usually you are using a LLM. So you can say that LLM is a AI system. LLM is a AI system which understands the understands the human language and also respond to you in a human language. Let's take guess, if you're asking any question to the chat GPT, you are asking in your language, and chat GPT is also responding to you in your language only, right? This is the kind of a AI system, we call it as the LLM, right? So the main problem here is that why we need a RAG, right? So first of all, why we need RAG? So the first reason is that LLMs are having a training cutoffs, right? I'm writing here. LLM have a training cutoffs. Remember one thing, guys. End of the day, if it is a LLM or any other model, right? If it is a LLM or any other model, if you talk about the large language model, if you talk about the small language model, right? If you talk about the diffusion, right? Any model you talk, end of the day, it's a deep neural network only, right? It's a deep neural network only. Correct. So obviously, if it is a deep neural network, definitely it's got trained on the humongous amount of parameter, right? If it is a neural network, means it got trained on the humongous amount of the parameters. Definitely, it's got trained on the humongous amount of the parameter here. Correct. Now, the main thing is it is already trained on huge amount of a parameter. It's already trained on huge amount of a data. If you are talking about the chat GPT, it's also got trained on the billions of a parameters, guys, right? That's why they are able to answer to our questions, right? But remember, guys, while training a LLM, definitely LLMs are having a training cutoffs. Training cutoff means what, guys? Suppose I have trained a LLM up to today's data, up to, let's say, today's data, right? Up to today's data means the recent information means what will happen tomorrow, what the day after tomorrow. This information LLM don't have, guys. LLM didn't got trained on this kind of a data, right? Means LLM didn't train on the recent data, right? So I can say that your LLM can't access training cutoffs means your LLM can't access a real time or a recent information, recent information, right? Because it is got trained up to today's data only, right? So that's a problem, that it won't have the recent information or it won't have the real time information currently, right? So to get that real time information, definitely we required some external retrieval. Okay, so usually what happen, guys, let me form a simple example, right? Usually what happen, so but let's take, guys, there is a one person, right? Right, let's take, and this person has a PhD in physics. Correct. This person has a PhD in physics. Correct. And we know that, guys, if he has a PhD in physics, means definitely he is a sharp guy. Right. Definitely he is a sharp guy. ऐसे ही PhD नहीं मिलते, right? So he's a sharp guy, definitely. So definitely he is good in reading, writing, and understanding a thing. Is good in reading, writing, and understanding the things. Simple. Correct. Now, guys, he is very good in physics. Means he is already trained in physics. Right. But let's take, guys, suppose I'm asking him any computer science concept. Let's take, I'm telling that I'm asking him what is database sharding. Suppose I'm asking this question. Or I'm asking you what is the replication factor for the Hadoop. Hadoop, default replication factor. Right? If I'm asking this kind of a question, do you think that this person will able to answer this question, guys? Do you think that this person will able to answer this question? Not at all, guys, right? Because he's already good in physics, right? But this person will not able to answer this question, unable to answer, right? Right? But what will happen, guys? Let's take suppose in a different way. This person is already PhD guy, guys, right? He thinks that he is very smart. And let's take, he taken a things on ego. Let's take this person has a ego. He is not able to accept that he don't know anything. He is not able to accept that he don't know anything. Correct? This is the problem. Now what he will do, guys, because of his ego, he will try to give the answer, any wrong answer. Means he will try to give a wrong answer with more confidence, right? Means what he will do, because of ego, he will give the answer confidently, because he thinks that he is very smart, confidently, correct? But that answer is a false answer. It can be a fake answer. Right? It can be a fake answer. Same to same thing will happen with the LLM, guys, right? LLM is trained up to the specific data, right? LLM don't have the recent information. But if I'm asking any new things to the LLM will try to generate the fake answer because he thinks that he is very good in reading, writing, and understanding, and he can answer anything, right? So this kind of thing, LLM will try to fake the answer, fake this answer, right? This concept we call it as the hallucination problem in LLM. This kind of problem we usually call it as the hallucination problem in the LLM, right? So usually, guys, the main intention about this retrieval augmented generation is what? To reduce the risk of the hallucination, right? How? Let me frame another scenario, right? So the main advantage of this RAG is what? RAG reduces the risk of hallucination in the LLM, right? Risk of the hallucination in LLM. Correct. Now, how? Let's take an example, guys. Right. So usually, what is happening? What same person? He's already good in reading, writing, and understanding. What if, guys? If I given him a system design book, right? Plus, I have given him some book called database concepts. Now I'm telling that do one thing. You take the help from this external resource. Take help from this external resource and give my answer. Means I'm telling that just look at this book, take this book as a reference, and please give my answer. Right? Now this person will able to answer this question, guys. Yes or no? If I'm giving this external resources to this person who is already smart enough, right? In understanding, reading, writing, right? And he is grabbing a thing faster because he is a PhD guy, right? So, guys, do you think that the problem is got solved? Yes or no? Right? So definitely, guys, he will able to answer. He will able to answer no. Right? So this is the use case of a RAG, guys. Definitely what we required because in a LLM, particularly in the LLM, training may not happen day to day, right? In LLM, training may not happen day to day. Training may not happen day to day. Correct? If the training is not happening day to day, definitely it won't have the recent information, guys. Right? So what in that case, what LLM will do? LLM is trying to get information from external retrieval. So here is the concept of RAG is coming, guys. Right? This is the first use case that we required a LLM to solve a problem of the hallucination up to some extent, guys. Listen, and remember one thing is I'm not telling you that the 100% hallucination problem is getting solved with the help of RAG, right? Up to some extent, I'm definitely telling that it is the hallucination is getting reduced. But I'm not telling that 100% the hallucination problem is getting solved because of only RAG. Correct? I hope guys clear everything up to here. Okay. Now the concern here is what guys means you need to give some external resources to the LLM, right? So that definitely it will try to retrieve the information from that particular external resources and definitely it is trying to give you the correct answers. Correct. Now the concern here is what guys that okay, I got to know sir, right? Suppose let's take you are having a company. Let's take you are having a company, you are running a company, right? Definitely, usually what happen, guys, that you wanted to use a LLM, right? Or you are building a LLM powered application, correct? AI powered application, right? And you think that, okay, I will give my database access to the LLM, right? I'm telling that we will give a database access, company database access to the LLM, company database access to LLM to give my answer, or to give, or let's say to give my answers. Right? This is the first thing, right? The problem here is, guys, the problem here is we know that it is solving the problem of the hallucination, because if I'm using a LLM don't know about your companies, right? What exactly there, what exactly going. He don't know everything internally what is happening in your company, right? But if I'm giving a database access to the LLM, definitely LLM can give you the answer based on the data that you are giving to the LLM, right? But the problem here is, guys, if I do like this, if I'm giving the access to the LLM for my databases, there will be the problem of a privacy compliance. Yes or no? Privacy compliance means what, guys? My company data is a private data, right? So if I'm giving access to the LLM, right, definitely what about the privacy of my data, right? Means I'm giving my entire private data to the LLM, and I'm giving access to the LLM, right? So this is the first problem, right? That we are having a privacy compliance here, right? So usually what happens, guys, what companies will do, right? Because what we want, our goal is what? We don't want open AI, right? To access our private data. We don't want open AI to access our private data, right? Because we wanted to keep our sensitive data in a control environment, right? Because we wanted to keep a sensitive data in a control environment. Right? This is the kind of thing I wanted to do, right? Because see, is using a RAG means I know it is solving the problem of the hallucination. It is avoiding the risk of the hallucination, right? But the main problem here is, guys, I have to give my sensitive data to the LLM. I have to give access to that to the LLM, right? So that's the reason, guys, most of the companies will prefers to host their own models, right? And they are making sure that nothing goes outside their ecosystem, right? Because this is the most important thing about the privacy concern. That's why I'm telling that most of the companies are having their own ecosystem, having their own ecosystems and model, so that the data will not go outside, so that the data will not go outside. Correct. This is the first thing, right? So I hope, guys, you are getting a things. What I told first, that why we need a LLM. Definitely LLM, why we need a RAG. Definitely your LLM is getting hallucinated, right? To solve this hallucination problem, we required some sort of a external retrieval, right? So here is a concept of RAG is coming, right? But the main problem with the RAG is what? That I have to give access to my sensitive data to the LLM, right? which is which is violating the privacy compliance, right? So that's the reason I'm telling that most of the companies are having their own models and their own ecosystem, so that nothing will go outside this organization, right? That is the first thing I'm totally clarifying here itself, because I know that your next question will be this: Sagar, if you are giving our private data to the LLM, what about the privacy, what about the compliance and all these things? Correct. This is the one thing, guys. Second thing, right? Second thing is, suppose let's take, if I'm talking about my companies, right? So we know one thing, that LLM don't have a domain specific knowledge, right? LLM don't have domain specific knowledge. Because let's take an example, guys. If I'm talking about can you let's take can you tell me that suppose let's take suppose I'm asking to the LLM that can you please give me the deduction in the salary of all employees related to the AI department. This is the question. If you give this kind of a questions to the LLM, guys, how LLM will handle, right? Because LLM don't know anything about this. He don't know anything about your company. How LLM will give this thing, right? How LLM will give these things, guys, right? This is the problem, no? Right? So that's why your LLM don't have a domain specific knowledge, right? And if you wanted to give a domain specific knowledge, definitely you are having a two ways, right? There are two ways to give a domain specific knowledge. Domain specific knowledge, right? First one will be a RAG and second one will be a fine tuning. First one will be a RAG and second thing will be a fine tuning. And we are going to discuss one of the way which is nothing but a RAG. Fine tuning we'll discuss later, guys. We'll arrange one more session to discuss about the fine tuning, right? But I hope, guys, you understand that your LLM don't have the domain specific knowledge. For example, if you want more clarity about the domain specific knowledge, I will give you the another information also. Let's take suppose I'm telling that hey LLM, can you give me the information? I'm asking that, hey LLM, let's see. Can you give the information? Can you give me the information about let's take Virat Kohli, right? So LLM already have a too much information related to the Virat Kohli, guys, right? So LLM already have a many resources, already have many information, right, about these things. बहुत सारे इंफॉर्मेशन ऑलरेडी एलएलएम के पास. बट अगर मैं एलएलएम को बोलूं नो नो नो, you go to the particular site, I want that specific site information which is having a personal information about Virat Kohli. Suppose I want a specific information from a specific site, from a specific website. LLM can't give this, guys. Right? I'm telling that okay, this there is a one website of a Virat Kohli school, right? And let's take in that there is a specific information related to the Virat Kohli. I want that kind of information only, right? We usually call it as the long tail information, right? But LLM will not able to give that specific information from the specific website, guys. I know that he already have so much information about the Virat Kohli, but if you are telling that give me that specific information, which is not possible, guys, in the LLM, right? This is the second thing I'm talking that why we need a RAG. Right? Because same question, if you correlate with the above question, that can you give me the deduction in the salary of all the employees related to the AI department in my company? He LLM will give you the all deduction from the different thing, whatever the information LLM have, right? But LLM will not able to give the specific information about your employees in your company, right? That's why our LLM don't have the domain specific knowledge, right? If you wanted to give a domain specific knowledge to the LLM, definitely you are having an option called a RAG, or another option that we are having, it's a fine tuning, right? I hope guys clear, right? Second scenario, guys, if you move towards the second thing, right? Okay, I'm just discussing about the need of a RAG, guys. I will frame a different kinds of a use cases in front of you so that you will get a much more clarity, right? So guys, remember, end of the day, more you know, better you will get, right? That's the first thing. Okay. Let me take a one simple example. Let me take a simple example. This is a very common example, right? Let's take a, have you heard about the in context training, guys? Have you heard about the in context training? Let me know. If you don't know, means I will frame the example. Have you heard about in context training? Everyone? Okay. Don't know, means let me, I will explain. Okay. In context training means, let's take guess. Okay. Remember one thing, guys, and first understand in a better way. That is the first thing. A second thing, understand the both engineering as well as the science aspect, right? Because end of the day, guys, nowadays coding becoming easy, right? People are telling, right? So you can wipe code entire rag also, right? But if you don't know these two aspect, you will never able to build any enterprise application using rag. That is for sure, right? So if you wanted to gain that level of a knowledge, so definitely you need to understand the engineering aspect as well as you need to understand the science aspect. Okay, so let me talk about the in context training example. Let's take, guys, you are running a one company. Let's say you are running a product based company. So assume that for us, for 10 minutes, you assume that you are a CEO of a product based company, right? Correct. Okay, now let's take, you decided that you wanted to build an enterprise application, right? You wanted to build a, let's take, you wanted to build a enterprise application. Sorry about this spelling mistake, guys. I'm a Marathi medium guy, है ना? So extremely sorry about this spelling mistake. Okay, fine. So build an enterprise application here. Okay, suppose you decided that you wanted to build an enterprise application, and let's take you are having a, you build it and you are having a particular product. Correct? You are having a particular product here, right? Now, what you want, guys, you want a product description for your product, right? Because now you are going to launch your product and now you are telling that I want a product description for your product, for the product. Correct? Now, guys, we know that product description itself is art, right? The way you describe your product, it will impact on your customer, राइट? जितना बेहतर वे में आप अपने प्रोडक्ट को डिस्क्राइब करोगे, definitely the customer is getting impacted because of this product description. Yes or no? Right? Let's take, because guys, different product requires a different kinds of a product description. For example, let's talk about, suppose you are having a laptop. Let's take, suppose I'm just giving the example. Let's take a laptop is one of your product, right? So if I wanted to give a product description to the laptop, right, you don't require any kind of a verbose information here, right? Means you, it's only things that you need to know. It's a configuration, right? That how much GB RAM, how much SSD, right? How which processor. This information is enough. But you don't require to know that why this processor is good, what are the technology they have used. We don't require any kind of a verbose description. We don't require any kind of verbose description here, right? But let's take, suppose I'm describing about the specific shoe, right, guys? Or if I'm discussing about the specific, let's take cloths, right? Definitely we required a verbose description, guys. Brief description we require. Definitely we require this kind of a brief description. Correct? So the main thing is what, guys? How the product description will be there is completely based on the product, right? And we know that the way I'm describing a product, it will impact my customer, right? Obviously. So I'm telling that, okay, LLM, just give me the product description for my product. Now the first question is, will LLM will able to give a best product description, guys? Because he don't know about your company, he don't know about your product, he don't know anything about your previous products, will LLM will give you a good answer? I'm not telling that LLM will not able to give the answer, but LLM will give you the best description here. Let me know, guys. Is it possible for LLM to give the best description in this context? No, guys. Right? LLM will not give you the best description, particularly in this context. Right? So here the concept of a in context training is coming. Right? In context training means same thing, guys, that we have discussed earlier. In context training means what? Obviously, your companies are having a database, right? Let's take suppose your company is having a database, and that database will contains the best product descriptions, right? That database is having a best product description. Now you'll get a doubt, sir, how database will having a best product description, guys? Don't forget, guys, you are a product based companies, right? So up to now, whatever the different products you have launched, you are having all sort of information related to that product, and what are the different kinds of a product description that you have given for that particular products, that is also available in your databases, right? It's already available in the database. Now the questions are, how the company decided that this one will be the best product description, guys? So usually, guys, companies will do this kind of a thing by using a different kind of thing. Most of the company generally use a A/B testing as a tool, right? That which product description is best, right? So you are having a this kind of a information in your product description database, right? So what I will give, guys, this database access, I will give to LLM. I will give to the LLM. Now tell me, guys, by seeing this data, LLM will give you the best product description. Now LLM has a domain specific data, right? He has a complete data about your all products. Now easily the LLM will able to give the best answer now, right? This is the advantage of the RAG, guys, right? This is the advantage of the RAG, right? Right? Clear, guys, up to here, right? I hope you got the clarity of the first thing, that why we need a RAG. Clear, guys? This is the first part. And I hope I have discussed the many scenarios. Shall I discuss few more scenario, guys? That where exactly the companies nowadays are using a RAG? Let me know. If you want, means I will discuss more scenarios. Right. Right. Okay. Okay. Let me discuss the more scenario. Let's take uh guys, one of the best company, right? One of my favorite company is Amazon. Let me take the example here. Let's take, guys, let's talk about the Amazon customer support. Amazon customer support. See, guys, Amazon is very famous for their customer support, right? Because they, till now, Amazon are having a good customer support compared to the other competitors, right? Now, the question here is, guys, whenever you are having a customer's support, definitely there can be many questions we are asking to the chatbot, or we are asking to the customer support. Okay. So let's take, guys, suppose I have built one customer support chatbot. Customer support chatbot. Let's take. And this is the LLM powered application. Let's take. Okay. This is the LLM powered application. LLM powered application. Correct. Now, this kind of a thing. Right. Now, definitely the customer will ask the question, guys. Right. Where is my order? This is the common question. Where is my order? Right. Or they can ask, why my package delay. Correct. There can be many questions the customer will ask, guys. Now, if I'm talking about this thing, right? Whenever you are training your LLM, Your LLM don't know the answer to this question, guys. That where exactly your order is, why my package is delayed, right? So the LLM don't know this information from the training, right? So when the time or at the time of training, at the time of training, LLM don't know about this question's answer, about this question. Correct? Because how they will tell that where exactly your order is there and all these things, right? So how exactly the RAG will solve this problem, guys? Right? Because customer can ask anything, guys. Where exactly the partner is now, right? What is his current location? Where exactly the things are there, right? Why my package is getting delayed? What is the reason, right? Many things, right? And suddenly LLM don't have the direct answer for this one, right? So what we will do, guys, instead of this in that, how RAG is solving this problem. Let me tell the RAG solution. Let me tell the RAG solution. Whenever the user asks the question, whenever the user asks the question, right? What LLM will try to do? LLM will try to retrieve a data. Right, let me write in this. LLM tries to retrieve a data. LLM is trying to retrieve a data from the databases. Like they are having a order database. Let's take different kinds order database. Let's take they are having a shipment database. See guys, Amazon is a big company. They are having a big data storage and definitely they are having a different kinds of. We are have a return policy. Let's take return policy databases, right? And many more databases, right? So it can retrieve from any of these databases, guys, and definitely LLM based on this LLM will try to generate a personalized answer. Correct? It's try to generate the personalized answer. That is the most important thing, right? I hope guys getting this one. This is the one of the use case that how exactly the RAG is getting used, particularly in this context. Right? There can be many application, guys. If you are doing a particular product search, right? Many things will be there, particularly, right? Even though not only Amazon, many companies are using this RAG systems, right? Because it's a need, guys, now, right? Because we have to give the external retrieval to the LLM, right? So here exactly nowadays there are many things, guys. There is a many agentic flavor is coming that LLM is trying to search, right? LLM is using a different kinds of a thing. There will be an agent who is taking a decision, who is doing a web search, who is retrieving the information from the different kinds of resources. Many things. That is a agentic flavor is came to the LLM nowadays, right? That's why. But we are here talking about the simple LLM, right? Okay. I hope guys clear. I hope you got somewhat much more clarity related to the LLM, right? Now let me talk about the system design part of the RAG, right? Because we are going to discuss here the RAG pipeline now. So let me talk about the system design part of RAG. Okay. So this is the most important thing, guys, that how exactly, because you will understand the complete pipeline of the RAG systems. Okay. Let's take, guys, now. Let's take you are having a data, and we know that we are having a humongous amount of a data. Humongous amount of a data. Okay? And we need to give this kind of a data to the LLM so that LLM can retrieve a data and try to give an answer, right? But remember one thing, guys, here that if you are having a huge amount of a data, no, guys, this is the second session, right? Whenever you are having a huge amount of a data, guys, right, we are having some constraint here, right? Agar, if you know about the LLM, guys, right, so definitely you are having a constraint. What is a constraint related to the LLM, guys? Anybody can tell? constraints. The constraint here will be you cannot give this whole data directly to the LLM, right? You cannot pass the entire data to the LLM, correct? Because there is a one concept called a context window. Have you heard about the context window, guys? Correct. Good, guys. So I'm telling that we cannot pass or we cannot give this entire data, right? Because we cannot give this entire data because we are having a limitation, right? Because we are having a limitation that we are having a context window. Nowadays, the context window is very big, millions of words that you can send and many things. Yet you will get on the YouTube, guys, previous recording, right? So you are having a context window. If you are trying to give more than that, guys, you need to pay more. If you are giving a more data, definitely the cost will be more. Cost will be more. If you are giving a more data, definitely the cost will be a more. Okay. So guys, the solution for this one, देखो, our focus is on we have to give a access to the external resources to the LLM, right? Hi sir, I'm from the non-tech background. Okay, let me. Okay, guys, we'll take a general question later. No? Obviously, guys, we are going to learn that thing only, that how you will connect your database to the rack, how you'll connect your external resources to the rack. But guys, before directly moving into the implementation, you need to understand how exactly the things are getting work. The problem with the people is what, guys? If I run a code in front of you, and if you copy paste same code and you run it, you think that you will become a AI engineer, right? I'm telling you one thing, guys, this is not at all going to help you, right? Right? That's the reason I'm telling, keep, please focus the things in both aspects, guys, because in the real time, particularly in the production environment, simply running this code is not going to help you. You don't know what are the issues are coming in the productions, right? That's the reason. Please understand the total aspects of the rack. Definitely, as I told you, our today's agenda is what? After discussing this rack pipeline, we are moving towards the basic embedding, and then we are giving an introduction to the LangChain, and I'm telling you how to implement this, right, with the help of LangChain, right? So just hold on, guys, and just understand the thing first, right? Otherwise, it will be a syntaxical game only for you. If you directly go to the implementation, it's a very easy thing. Just I'm sending a command, you run it, and you get it, like kind of a thing. Right? But remember, guys, if you're from any background, again, if you're from a technical background, if you're from a non-technical background, don't think like this that you are from the non-tech background. Ab kya hoga? Right? The reason why I'm telling guys, if you are from the non-tech background also, but currently you want a job in a technical na, so why you are getting scared of a technical? अगर आपको technical job करना है तो, if you wanted to do a technical job, you have to learn the technicality, guys. Then only you will get it now. Right? So don't think, first of all, don't think in this way, I'm a non-tech and all this. Definitely you are a non-tech, no worries. But you are becoming now technical now. So that's the reason I'm telling focus on the things, guys. Okay. Anyway, fine. Okay. So the constraint here is what? We cannot give an entire data, guys. So we are having a limitations of the context window here. And if you are giving a more data, definitely it will be a huge cost, right? So how you will give a data to the LLM? This is the most important thing, guys, right? So what you will do, we are having a mini strategy. So what we'll do first one, we'll take a data, right? And apply some strategies. Strategies. I will tell what are the strategies, right? That one of the strategy we call it as the chunking, right? Chunking means what, guys? You don't give an entire data, but you give only relevant data, right? So you cannot give a entire data to the LLM na, so better to give a relevant data to the LLM, right? So that it will be fit in the context window, right? So instead of giving a entire data, right? Give a relevant data, so that it will fit, so that it will fit, it will in fit in context window. It will fit in the context window. Okay, that is our goal. So we'll give a relevant data so that it will fit in the context window, right? So to do this kind of thing, we'll use a strategy called a chunking. I will come to the chunking, guys. Don't worry. We'll use a strategy called the chunking, right? So chunking is helping you to only retrieve the relevant information, right? So why I'm telling that chunking is helping you to get only a relevant information, to get only a relevant information, right? Because our constraint is what, guys? Our constraint is a context window, right? So we have to give the optimal information in the context window. Our goal is what? Our goal is to give a optimal information in a context window. Means what? Optimal information means what, guys? Not too much far or not too much little, right? Or I can say that neither too much, neither too much nor a little, neither too much nor a little. This kind of a optimal information, we need to give it to the LLM, right? Before LLM process the query, right? Remember one thing, guys. We are giving this information before the query is getting processed, right? Because based on the query and based on this chunks, LLM try to generate the prompt, right? Try to generate the answers, right? So that is our goal, that we need to give a optimal information in the context so that it is getting fitted into the context, and make sure that whenever you are giving information to the LLM, it's not too more or too little information. That's why they have used the word called optimal here, right? That optimal information that you need to give it to the LLM, right? So guys, to those thing here, the main thing is that, guys, we need to give a optimal information here, right? So wherever the optimal word is coming now in a computer science or in the industry, we require a lots of engineering here, right? We required a lots of engineering here, right? Because we need to optimize this strategy called a chunking, right? Because we need to optimize this strategy called chunking. We need to optimize the strategy called chunking here, right? So this is the engineering aspect of the RAG, that where exactly you need to think that how exactly I will optimize the chunking, because we're not able to pass the entire data to the LLM, right? Now, if you talk about the science part here, right? I told you that you need to know both aspect. You need to know the engineering aspect as well as you need to know the science. Science part is what, guys? How exactly the retrieval will happen? How exactly the embedding? How exactly the semantic search will be done? This is the science aspect, right? That how exactly the retrieval will happen, how exactly the embedding will happen, right? How you are using a similarity search to retrieve a top vectors like this is the science part. But the engineering part will be this optimization, and wherever the optimization will come, guys, software engineer will come there, right? Fine. Okay, now the question here is, guys, that we need to optimize a chunking, right? And that's why we are having a mini chunking strategy, guys. We are having a mini chunking strategy. Mini chunking strategy. If you start about the, you are having a fixed size chunking, right? You can have a recursive chunking, right? You can have a late chunking. Right? You can have a late chunking. Right? You can have a semantic chunking, many chunking. You can write an entire book on chunking, guys. Semantic chunking, agentic chunking, many things. Even though you can write an entire book on chunking, there's many chunking strategies out there, right? But the main thing is what, guys? The main thing here is because you're going to work in the production environment, right? So you need to decide, right? As a AI engineer, you need to decide for our data which chunking techniques is a good, right? For our data, which chunking technique is good, right? But I'm telling you one thing, guys. There is a no guaranteed technique or no guaranteed chunking techniques will work best. I'm writing here. There is no guaranteed technique. No guaranteed techniques will work best here. Right? Right? So what is the approach, guys? What is the approach you can use here? I'm already telling guys, you should be a good problem solver, right? That's why we are focusing too much on the problem solving in the sessions, right? Here, literally, I'm telling guys, because here the engineering approach will definitely pays you, right? Definitely pays you, right? Because we are having so many techniques, guys, right? And we need to find out the best chunking techniques here, guys, right? Remember, guys, if you there is a two things now because to handle this kind of a thing or to use a particular approach for this kind of a thing, you are having two different kinds of a people. If you are a fresher, if you have experience, experienced people are already went through this kind of a scenario, right? And by their experiences they have gained that okay, this chunking will be beneficial here, it will work better in this case and all these things, correct? So that is a one aspect, guys, right? Other approach will be you can use DP, guys. You can use a Anyway, guys, DP is not only a programming techniques, but it's approach, right? You can use a dynamic programming approach that you try with a different strategy of a chunking, and based on that, you are trying to figure out the best one, right? That the things that you are doing in the hyperparameter tuning, right? Particularly in the grid search approach. Grid search approach is also a DP approach, right? So same thing, guys. We can use a dynamic approach here that will try to figure out the different kinds of a strategy, and among that, we'll try to pick the best one, which is work best for my data, right? This is the most engineering aspects here, guys, that we are using for a chunking, right? But guys, here today's session we can't go too much into the chunking, different kinds of a chunking. But I'm telling you that how exactly we will give a data to the LLM, right? We cannot give an entire data to the LLM. That's why we need to give a data in the form of chunks. And to this kind of a chunking, we are having a different kinds of a chunking. And based on your data, your problem statement, you need to select the appropriate chunking here, right? So you use any strategy, right? But generally, if you're a fresher, you will use a DP approach, right? Right? That you will figure out all the chunking techniques and will take the best one, which is working the best, right? Install and set up. What install, guys? Let me know what you wanted to install. Yes, anyone? Any doubt, guys? Let me give 1 minute. Don't require to install anything, guys. Don't worry. When the implementation will start, you do with me, Hannah. So you will able to do it. Don't worry about the implementation. That's why I'm telling you, please listen whatever I'm telling first. I know you are too much focusing on the implementation, but limit and guys, whatever the beautiful project you build on the RAG, na, I will ask only two questions based on that project. If you are not able to answer that question, means what's the use of that product or what the use of that project? Literally, I'm telling us where exactly the peoples are failing. They think that they will build a beautiful projects, right, on the basis of RAG and LLM and all this thing. End of the day, guys, everyone know I can build a RAG from the scratch without using any external library. Okay? What you need to do, you just have to use a proper prompting. That's it. Nowadays, building a project is not a major task, guys. 20 minutes, 30 minutes, you can build any beautiful project. That is not a major task, right? But how you will handle this thing in the production? If anybody asks you the question which is related to the real time, and if you're not able to answer, how you will justify yourself that you have work on the rack? That is the most important thing, guys. That's the reason I'm telling. It's not about the sorry, guys. I'm telling you the approach that you people are following. Right? That is completely a wrong approach, guys. It is not going to help you. फिर बाद में आप ही लोग बोलते हैं सर there is no job. Right? I know this thing, I know that thing. 6 पेज का resume होता है आपका. Right? So it is not going to help you. Right? Anyway, okay. Now let's talk about the second thing, guys. Na? Here, this is the chunking approach that how exactly the things are done, right? Second thing is what, guys, that how exactly a particular things is getting stored, right? Because you have created a chunks now, right? Definitely you have created the chunks. Now what you need to do, guys, that data you need to store it, right, you need to convert that into the embedding vectors, right? So the second thing is what, that you are having a chunks now. Now you are storing that data into the form of embedding vectors, right? So here the most challenge here is now how to do this kind of embedding, right? Because you should have an embedding model, right? Because you want it to get a relevant thing now, right? So let's take a simple example, guys. We know that how exactly the things are getting done, and we have already discussed about the cosine similarity concepts, right? But let me tell you one thing, guys, about the this entire process that we are using a vector databases in this case that suppose I am having a huge amount of a data. That's a huge amount of a data of a PDF. Let's take. I cannot give the entire PDF to the LLM, right? So what I will try to do, I will convert this data into the vectors, correct? And that vectors data I'm trying to store it into the vector databases. Right? I'm trying to store that data into the vector databases. Correct. And based on my query, I will try to retrieve the top relevant records. This is my scenario usually that I'm trying to do here. Correct. Now, what you will do, guys, here, suppose let's take, suppose let's take, I'm explaining embedding in very short way, guys, because we don't have that much time, right? So you're waiting for the implementation. So I will give a simple introduction to the embedding and then we'll move towards the next part. Okay, listen now. Suppose, guys, let's take, I'm having a data. Let's take, you are having a data. Uh, you are having a various kinds of a documents data. Let's take, I'm telling, let's take, you are having a documents here, right? And let's take in the documents, let's take, suppose you are having a few documents here, right? How, guys, you will get it, right? Fine. Let's take in the documents data, let's take, suppose you are having like this, let's take any example, any fruits. Let's take apple. Right? This is the let's take this is the document one. Just for simple understanding, I'm taking here. Let's take this is the document two that you are having. Let's take you are having a document. Let's take aeroplane. Let's take these are the two documents that you are having, and let's take this is the document are getting stored in the form of vectors in the vector databases. Right? This is stored in the vector DB here. Correct? Right? If you use the API key to build a custom RAG chatbot, doesn't that API key have access to our company's data? Okay. No, guys, not at all. Right. Fine. So here you are having a vector databases, right? Remember one thing, guys. Obviously, if you are giving a access, right? If you are using a building a custom RAG, and if you are giving an access, obviously you will take care about the compliance, right? Right? You will take care about the compliance, right? So you think that through API keys you will able to access your entire data external your outside of your ecosystem, right? Not at all, guys, right? Okay, so you are having a documents D1 and D2, Apple and Aeroplane. I will come to that one, guys. Just to hold on, है ना? Right? So you are having a documents D1, D2. These are the two documents. Let's take Apple and Aeroplane. Let's take I'm given here any query point. Let's take I'm giving here any query point. Right? Let's take suppose I'm telling that let's take any query point. Let's take grapes. Right? Given here, let's take grapes. Correct. So what it will do, guys, whenever I'm given a query point grapes, right, it will give me let's take similarity score. Right. We know that we have learned the cosine similarity. It will give you let's take similarity score. Let's take I'm getting here. You are having an apple, right? And you are having an aeroplane. You are having an apple and you are having an aeroplane. Correct. Let's take in this case, suppose whenever I'm trying to compute a similarity score, let's say you are getting a similarity score here like the 0.78 something, right? And let's say you are getting here the score at 0.22 something like this. Okay. So if I see this similarity score, that I will able to find out that this is my query, which is a grep, right? This is my relevant vector. This is the vectors are present in my vector databases, right? And what it is giving me, this is giving me the relevant vectors, or let's say relevant document, it is giving it to me. Right? So it is giving the highest similarity score for the Apple. And let's take that they are using, this is the lowest similarity score, which is a 0.22. This is the relevant thing they have given to me. Right? Now the question here is what, guys? That if you observe this one, if you observe this one, अगर आप इसको सही से observe करोगे, तो we know that there is a relationship between grapes and apple, right? Grapes and apple, right? Because both are fruits. This is the one thing you can, this is the common sense, guys, that we can discuss that both are fruits. Okay. Now the concern here is, what, guys? How they are giving this kind of a thing. Okay, I know that you have used a cosine similarity here. You have used a cosine similarity, and based on the cosine similarity, you are trying to give this kind of a score that okay, these are more similar, grapes and apple. That's why you are getting a highest similarity score. But can you tell me the intuition behind this, guys? That why it is giving a high cosine similarity score? Forget about the formulation, dot product, converting about the vector. But what is the intuition here? The intuition will be like this. If I'm asking you probability of what's the query point given? The query point given is a grapes. The probability of grapes given apple and the probability of grapes given aeroplane. Correct? This will be a very high. This probability is very high compared to this one. This probability is very high means what, guys? This grape words comes more number of times with the apple than the aeroplanes. Right? That's the way that we are trying to retrieve vectors based on the semantic meaning, or we are trying to retrieve the word based on the semantic meaning. Right? This is working fine, guys. But what if suppose this we call it as the distributional hypothesis, good. But I don't want it to go to similarity, that kind of a wording. Okay. Let's take suppose I'm changing here. Let's take suppose I'm changing here. Right? Suppose I'm changing here. Let's take you are having a vector database here, right? Here you are having a vector databases, okay? And in this vector databases, let's take, guys, you are having a grapes, or let's take you are having a grapes, right? Let's take you are having a anything. Let's take Samsung. Let's take you are having a Samsung, right? And let's take you are having, let's take these are the two things you are having. And let's take I have given a query point here. Let's take banana, right? Let's take I have given a query point here, banana. Okay. Now, if you observe this one, guys, if you observe this one, right? I'm given here Samsung and my query point will be a banana and you're having a grapes here, correct? Now, guys, if you observe here, suppose let's take, because whenever you are doing a semantic search, now guys, this thing usually happen, and this is happening at the production level, right? So whenever you are having a grapes and whenever you are having a banana, listen. So usually what happen, guys? If this Samsung has given the highest similarity score, highest similarity score. अब आप बोलोगे सर कैसा? Right? Remember one thing, guys. Google has one model called Nano Banana. Have you heard about this? Yes. Which is a Nano Banana, right? So what if, guys, they are capturing that kind of information and it has given a highest score to this Samsung, right? So in that case, this will get a highest score and this will get a lowest score, correct? This is the one aspect, guys, right? But let's take suppose, I'm framing another scenario. So let's take suppose same vector database you are having here. Let's take same vector database you are having here. Okay. And let's take in this vector database, you are having, let's take grape, right? Let's take you are having a same Samsung. Correct. Now let's take I'm typing here query point Apple. Right? So now still you can correlate, guys. This Apple means they can talk about the company. And here Samsung also company. Right? You can get a better similarity score in this case also. You can get a higher similarity score. But guys, suppose instead of apple, suppose I have written here ripe apple. Right? Instead of simple apple, if I write here ripe apple, I will get a more similarity score with the grapes only now. Yes or no? I will get a highest similarity score with the grape because I'm talking about the ripe apple. Right? So if I wrote the apple, it is giving me the more similarity score with the Samsung. Right? But if I use a ripe apple, definitely it is giving me the more similarity score with the grapes. Correct? So what is happening, guys, here? If I make a small change here, if I make a small change here, right? My entire result is getting changed. Right? My entire result is getting changed, guys. If I make a small change here, my entire result is getting changed here. Right? This is the problem with the embedding, guys. And if this kind of problem happen at the production level, how you will handle, guys? Right? If this kind of a problem is happening at the production level, the main thing is how you will handle this one, right? That's why they have included a concept of a re-ranking in the rack pipeline, right? So to handle this kind of a problem, to handle the problem of cosine similarity, where it gets fail, right? There is a one what we can say one stage they have adding. There is a one stage which is nothing but the re-ranking. Right? Re-ranking. Re-ranking means a simple thing, guys. है ना? Usually what happen, right? Whenever I'm telling that, okay, whenever I'm telling that, usually what happen, guys, listen. Suppose let's take you are searching for a, let's take simple, in a simple word, let's take the example. Let's take, suppose you are searching for a apple. Let's say you are searching for apple, and let's take, whenever you are using, suppose usually guys, first of all, the LLM is located into the vector databases, and in the vector databases you are trying to get a top k relevant vectors. Okay, I'll get a top k relevant vectors here. Okay, let's say guys, suppose I got here vector 1, I got here vector 2, right? I got here vector 3, so on, so on, so on. Let's take, I got here vector vk. They are the kinds of a vector that I got here. Correct. Now the concern here is, guys, the same scenario has happened that the cosine similarity is getting failed in some of the context, because if there is a small change in the word, there will be an entire change in the everything. Right? So what they are telling to do, only searching a relevant vector into the vector databases, it's not giving you the guarantee that you will get an exact answer. Right? Because what if, suppose guys, if my query point is Apple and LLM is giving me a Samsung, right? Because this is not at all going to work now, right? And if I change ripe apple, then it is giving me the fruit, right? So the problem here is only simply searching into the vector databases and getting an answer. It is not at all going to work in all the cases, because sometimes definitely your cosine similarity will get failed here. So what they have introduced, they have used the concept of a re-ranking, right? Because see guys, I'm not discussing here architecture, that encoder and cross encoder architecture of the rack that you explore, right? Because again, you will tell that the session is going too much theoretical, sir, right? So that's why we'll skip that part, right? Okay. So what I'm trying to say in this case, that you are having an apple here, and I'm retrieving the top k vectors here, right? v1, v2, v3, v4, like this vk, right? And you are having a vector, this is your query vector, guys. Now I can do a re-ranking, guys. Re-ranking means what? Definitely you sort it based on cosine similarity. Cosine similarity. Kaise? You take, now guys, listen one thing. Earlier problem was what? Recall our first problem. I am having a particular VQ. Let's take my query vector is given. This is my query vector. And I am having a billions of vector in my vector databases. Right? And what I am trying to do, with each vector, I am trying to find out the cosine similarity. Right? Each vector means I am finding out VK to V1, this cosine similarity, VQ to V2, for with all the vectors I am trying to find out the cosine similarity, and then among that I will find out the relevant one, right? And we know that this is the huge problem, correct? We cannot go in this way. That's why we have learned the different algorithms. We learn the LSH, KD tree, HNSV, this kind of algorithm to make this kind of a thing faster. Okay. So that's why we are using the concept of approximate nearest neighbor. We are okay to compromise with accuracy, but we want a result faster. So that's the reason we are going to use your approximate nearest neighbor in this context. Okay. So same thing, guys. I'm telling that, okay, once you got a top relevant vector, let's say guys, k value is, let's take 100. मान लीजिए it's 100. So guys, what you do, you find out the similarity VQ. This is your query vector with the V1 cosine similarity, VQ with this V2, and so on, so on. You find out the cosine similarity of VQ with this V100, guys. Correct? And sort them in a descending order of, right? Sort them in the descending order of scores, right? So if you sort them in the descending order of a score, you will get an exact answer, guys, right? Because instead of searching, now you will get a doubt, guys. Immediately you will get a question. Sir, हमको यही नहीं करना था कि that we don't wanted to find out the cosine similarity from each vector, right? That's the reason we have used a different sorts of algorithms here, right? That we don't want it to find out the cosine distance from every vector. Guys, remember one thing, guys. Here we are not finding the cosine similarity of your query vector to each and every vector present in the vector database. Here you are trying to find out the cosine similarity only with the top relevant vector, right? Because I know the first question the software development engineer will ask here, okay sir, you are doing this thing, but what will be the time complexity in this case, right? So time complexity less only, guys, because to get here the time complexity will be less to get, because time complexity is less because to get a relevant vector, to get a relevant top k relevant vector, we are using a approximate nearest neighbor, guys, right? So once you got the relevant vector, now you find out the cosine similarity and then get the best one, right? Relevant answer. This is the second phase, which we call it as the re-ranking in the RAG pipeline, guys. Let me know, guys, up to here clear, everyone, that how exactly the things are happening, right? So guys, there is a one thing called RAG architecture, right? That where exactly we are using a encoder, we are using a cross encoder, right? Generally, to do a re-ranking, we are using a cross encoder, right? If you go to the architecture of this RAG, you will get to see. But this RAG architecture, which is an encoder and cross encoder, encoder and cross encoder based architecture, you explore, guys. You explore by yourself, right? I hope, guys, up to here clear, right? So this is usual a pipeline of the RAG, guys, right? So usually hota kya hai, guys? Simple. If I explain you in a single line, what will be the RAG pipeline? Initially, what happened, guys? User will give a query. This is your user query, correct? User will give a query, right? So what will happen now? Whatever the query you are giving, right? That query should be converted into the vectors, embedding vectors, right? So here you are having a query encoder, right? So obviously you are having a query encoder, right? And this will contains the embedding model. Those who don't know encoder, decoder, guys, don't worry. Because once you learn the transformer architecture, particularly from the character RNN, we'll discuss that encoder, decoder, BERT, and all this kind of architecture, right? Now you will get a query vector here. Once you got a query vector, guys, you will search into the vector databases, right? You will search into the vector databases, correct? I'm just explaining the sequence and now we'll start the LangChain, guys. Embedding will happen at QKB matrix, so that re-ranking will happen on this matrix, correct, guys? Correct, correct. Okay. Those who don't know, guys, don't worry, Hannah. This is not too much difficult concepts, right? Very simple. I already told you guys, this data science and AI is full of fancy words. End of the day, after learning, you will find out that nothing will be there. Literally. है ना? Because it's not that much difficult. जितने नाम लेके लोगों ने difficult किया. Right? So you are getting your vector databases, right? From the vector database, let's take I'm getting a top 100 vectors. Right? From the vector databases, let's say I'm getting a top 100 vectors. Now what will happen, guys? Once you got a top 100 vectors, I will do a re-ranking, right? For that, I'm using a cross encoder, right? So probably I will use a cross encoder, and with the help of this, I will get a whatever the top 3 4 whatever the relevant vector I will get here. So I'll get the top 3 4 or 3 5 most relevant vector, most relevant vector. Once you got the top most relevant vector, right? Obviously, guys, there will be the prompt construction will happen. So you are giving this relevant vector and your query vector, this both things you are giving, right? So you are having a context, this context vector, most relevant vectors, and your query vectors. right? These two things you are giving it to, giving for the prompt construction. And here the LLM will generate the answer. Right? Then your LLM will generate the answer. Simple, guys. Right? This is the exact flow of the RAG, guys. I know I explain in very high level, guys, but very less patience the people have, right? They directly move it on to the implementation. That's why we have seen in very high level that how exactly the RAG will work. Right? Clear, guys? Let me know up to here any doubt you have. Clear, everyone? I hope, guys, you can speak now. So I have covered almost this thing. Let me introduce the lang chain, guys, and we'll do this small implementation. Right? Right. Okay. So what we will do, guys, we'll implement a small use case, right? How exactly the things are getting searched. एक काम करता है कि simply what we'll do, we'll take one simple PDF, right? We'll store into the vector databases, and we are asking you to give the answer to our question based on that, right? And the RAG exact implementation using the OpenAI keys and all this thing. Probably we need to plan again one more session, right? Because that's the time limit, guys, right? Fine. Okay. Okay. Let me introduce the lang chain, guys, here, right? And then we'll implement the things. Okay. See, guys, there is too much thing to discuss here. Already I told, because it's not a simple thing that you will directly start the implementation and all this thing, because you have to know many things, then only there is a chances that you will get something in this, because it's not a short thing like a एक concept बताया program लिखा और हो गया, right? This is not going to happen in that way. Correct? Fine. Okay. So let me introduce about the LangChain. I'm giving a short introduction to the LangChain because those who don't know. Right? Correct. So LangChain is an open source framework, guys. Right? You can say that whenever you wanted to build a LLM powered application, so LangChain is nothing but the framework, or you can say that LangChain is an open source framework to build a AI powered or LLM powered application. Right? To build the AI powered or LLM powered applications, right? So usually, guys, suppose whenever you wanted to integrate your application with the LLM, definitely you required a LangChain. So it is used to integrate the application with the LLM. Definitely we required a LangChain. Definitely we required a LangChain. Simple. Okay. So usually, guys, what LangChain will provide you, right? LangChain will provide you the classes for the different kinds of LLM, right? And through that classes, we will able to access a specific LLM, right, in our application, right? Just like for example, guys, let's take if you are having a application. Let's take this is your application that you have built. Let's take this is your application, right? Now, suppose you wanted to integrate this application with the LLM. So LangChain will provide you this kind of, you can call it as the one kind of a business layer, right? जैसे कि आमतौर पे application पे होता है, right? So this is the kind of a LangChain that providing you the framework. Why it is calling the LangChain, guys? That philosophical answer we don't want, right? Okay, fine. So here you are having an application and you wanted to integrate with the LLM, right? So what LangChain is providing you? LangChain is providing you the different classes of a LLM. Let's take you are having a LLM here, right? And you can have a different LLM, guys. You can have a GPT, right? You can have a Gemini, right? Even though you can have a many Llama, Mistral, right? So different kinds of LLM that you have, and based on which LLM you are going to use, that kind of a class is provided by the LangChain, right? So suppose I am using a GPT LLM, right? So definitely LangChain will provide you the class called Chat Open, right? Chat Open AI, right? Suppose I am using any other model, right? Let's say suppose I am using a Gemini, then it is providing you the Gen AI class for that particular for using that particular LLM. So it is providing you the different kinds of a classes to interact with that particular LLM, guys. That is the use of LangChain here, right? So whenever you are creating a LLM powered application, definitely you require a LangChain, right? Now, how exactly the communication will done? The communication is getting done through the API, guys, right? I hope you are aware of the concept of the API, right? Yes or no, guys? Right? If you don't know API concept, guys, please explore. है ना? Otherwise, we'll take it in the class, because in the class we'll teach you everything. है ना? Because we assume that you don't know anything. So we'll teach you what is API, how exactly to create a APIs, right? And how exactly it is working, right? So this is your application, and this is your LangChain framework, right? This is your LangChain. Right? In a simple word, I'm trying to explain you what is happening. It is providing you the different classes, right? So you can have a chat, open AI, right? Many classes and many things, particularly that you have many classes, right? And here is you are having a LLM, right? So your application is communicating with the LLM through this framework only, right? So initially you are passing an input to the LLM, right? This is the input, sorry. This is the input that you are passing to the LLM, right? And you are getting output, right? And this is obviously happening through one API call, right? This is happening through API call, right? Right? This is happening through the API call, right? This is the general structure that the LangChain is providing to you. Okay. So usually, guys, suppose if you are building any web application, right? Let me explain in a different manner. Suppose you are building any web application. Usually, user is there. Let's take this is the user, and user is using your application. This application is definitely on the, let's say you are having a web app. So definitely you are having a web server, right? On the web server, your application is running, right? Let's say this is your web app. Your web app is running on the web server, correct? Now, this is the general, you can say that this is the two-tier architecture of the database, right? So here you are having a database which is running on the database server, right? So usually user is requesting through the application, right? And it is responding, right? Just like a client, normal client server architecture that you have, right? So now, guys, this is the conventional application that you have. But nowadays, the application should be a AI powered. Means what? Your application wanted to interact with a LLM. So here exactly the new layer is getting added, which is nothing but a LangChain. You can consider this as the one kind of a business layer, right? So you are sending an input and you are getting output like this. And through this LangChain, I can communicate with the LLM. For that, I'm using here API call, right? So the simple things, right? So your LangChain is using the API, guys, right? So internally to communicate with the LLM, definitely the LangChain is using the APIs, right? So you can consider this is the kind of a, rather than saying a business layer, you can call it as the management layer, right? You can call it as the management layer in the application, right? Where exactly your application wanted to communicate with the LLM. Clear, guys? I hope everyone understood. Yes or no? What exactly the LangChain, guys? This I'm trying to explain in very high level, right? Because we are having a limited amount of a time, right? That how exactly the things are getting. I hope, guys, clear everyone. Let me know. or do I need to explain it? Anything? Yes, anyone, any response? Okay. Now do one thing, guys. I will show you the small demo that how exactly the things are getting work, particularly in this case. Particularly what we'll do, we'll upload one PDF, right? And let me explain you the things. Okay, let's take, guys. Could you please do with me? Guys, we are using a rag only for that, no? To search in the databases, right? But guys, agar if you are having this kind of a doubt, na, let me tell you, है ना? Don't think in this way, na. Suppose let's take I have a data like this, but this is the kind of a production level issue, guys, है ना? Usually आप general project बना रहे हो तो you won't get that. But let's take suppose I am having a data like this. Just let me raise the one scenario question. There can be many scenario question, guys, but it is getting asked for the experienced people, no? Right? For example, let's take I have a data. Let's take PDF data hai, right? And it is having a data about the company. Let's take company and let's take revenue. Right? Let's take you are having a company ABC and let's take I'm having a review. Let's take 10,000 crores like this. Okay. Let's take I'm having a XYZ, right? I'm having let's take 20,000 crores. Okay. Right. Let's take I'm having a company PQR. Let's take I'm having a 15,000 crores. 15,000 crores. Let's take suppose this kind of a thing is in front of you guys. Correct? Now the question here is, guys, suppose I ask the questions to the LLM like this. Suppose I'm telling that my concern is like this. Can you please tell me which companies are having the highest revenue? Right? So you are having a company list in this one. And I'm asking you that can you tell me which companies are having the highest revenue? Do you think that the LLM will able to answer this one, guys? Let me know. Anyone? I'm telling that. Can you name the company or let's take name the company which is having or let's take which is having a revenue greater than 10,000 crores? This is the kind of a question that you have, right? So you have given a PDF of this one. And my question is, can you answer that? Can you give me the name of the company which is having a revenue greater than the 10,000 crores? Right? So guys, if you ask this kind of a question, the main thing is what? Your LLM, right? And even though you're embedding is very famous to capture the semantic meaning, right? It will not do this kind of arithmetic operation for you, right? This is not performed because everything, it's not possible, right? If you directly given these questions to this LLM, it will not able to do it, right? Because if you given this kind of a document and if you're asking you that which company is having a review, obviously this entire document is getting converted into the embedding vectors. First thing, right? It is getting converted to embedding vector, correct? And whenever you are doing embedding, guys, you know one thing that embedding is getting done on the basis of semantic meaning. It will not understood that the 20,000 crores and 50,000 crores is greater than 10,000 crore. This is this is not be done by the embedding, right? They will capture the semantic meaning, right? So what embedding will thinks that all these vectors are very closer because they are having these numbers, right? This is the usual thinking of the embedding, guys, right? So to solve this problem, right? To solve this problem, what we need to do, guys, right? To solve this session will be available on YouTube, guys. To solve this problem, guys, we need to do a different things. With the embedding, with the embedding, we need to use a structural retrieving, because this is not possible with the only embedding, right? Where exactly you need to give, it is available on YouTube, guys, है ना? We can't personally share, right? So it is, we with the help, with the embedding, you need to use a structural retrieving here. Structural retrieving means what? We have to use a general SQL approach, guys, right? Because this is the numerical query, guys. This is what? This is a numerical query. This is the numerical query. Correct. So the question was that now that sir, it can communicate directly with your any database. We have discussed up to the vector database. I'm talking here about the other database which is having a structural information, right? And whenever you are having that kind of a question which is related to the structural information, your embedding will fail, guys, there. It will not do any kind of a comparison here, right? So definitely we are using a structural retrieving, and literally because of the structural retrieving, we are simply writing a query and it is giving me the result, right? See, guys, you are having a various approaches here, right? Because I don't want it to go into the agentic flavor, but definitely your agent can take a decision that it will convert this query into the SQL query, right? Your query vector into the SQL query, and it is getting applied on the database, and you are getting the retrieval from the database, and it is again converted into the prompt. That kind of thing is also happening, right? Or if you fine tune your Google BERT to convert the natural language into the SQL query and you will get it, that is also possible, right? There can be many things. That's why I'm telling that the solution for this one will be a structural retrieving, that you required a query here, SQL query, to retrieve that particular information from the databases, right? Because your semantic meaning, your embedding will not solve this problem here, right? And there can be many common issues, guys. ये कुछ भी नहीं है. There can be a many common issue will happen in the production. Many common issues will be there in the production, right? If I raise one, can I raise one more scenario, guys? Again, guys, I'm telling that this level of a question they will not ask to the fresher, है ना? But I'm telling you one thing, because if you are working in the production environment, guys, क्वेश्चन बोल के नहीं आता है कि what is happening, right? And even though, guys, there is a problem with this kind of embedding, because suppose I am having a data like this now. Suppose let's take this as the data where the characters are associated with a number, right? So you have to use a different kind of embedding techniques also, right? That, guys, will wrap up, right? We'll wrap up, don't worry. So we are having other techniques like a RM25, BM25, this kind of a techniques, right? Particularly in the case of embedding, right? Fine. Where we are doing a key value based embedding, right? Fine. Fine. Okay. Okay. Let me take a scenario too. See, guys, that you need to decide now, right? Now that you need to decide whether the RAG is useful in your use cases or not. That you need to decide now, right? Whether you wanted to use a RAG or not, right? That you have to decide. Correct. Because see, guys, nowadays now everybody wanted to use AI. Literally, I'm telling. And the main thing is what? Whether the problem statement is related or not related, but everybody wanted to implement the AI. So you need to convert that problem statement into the classical AI problem statement, right? That you need to decide whether I have to use it or not. Right? But definitely, guys, you will use it. Right? Okay, fine. Okay, I will raise one question, guys. You try to answer this one, and then we'll move towards the practical, right? So let's say, guys, suppose I'm talking here about the PDFs. Let's take you are having a 80 millions PDF, correct? Right? And we know that you cannot give this 80 millions data to the LLM, correct? So what you will do, and let's take you are having a chunks. Let's take 2 billions chunks. 80 millions PDF, and you are having 2 billions chunks. My constraint here is what, guys? The constraint here is My constraint here is whenever I'm trying to retrieve a specific thing, it is taking a 5 second to give me the relevant document, right? But what I wanted to reduce the latency here. I wanted to do it in 1 second, right? It is taking a 5 second earlier to get the my relevant vectors, but I wanted to do it in 1 second, guys. Now the question is how to solve this, right? You think about this question. I'm throwing the question in front of you. Right? Fine. I hope guys up to here clear everyone. Any doubt? Let me know. Please guys let me know any kind of a doubt that you are having here. Okay. No streaming. Streaming is not a good solution, guys. Think as a software developer point of view. Okay, guys, let's talk about the implementation now. See, guys, already I'm using a different levels of indexing here now. IVF, I'm using HNSV, many indexing techniques that I'm using here, right? No wrong chunking, guys, right chunking. That you will decide before doing a chunking only, na? Right. Okay. Anyway, but I will tell you one solution, guys. One of the solution will be a database sharding from where I started the session, right? One of the solution will be a database sharding. Although it's a software development concept, but guys, definitely 101% where the problem is not in your hand, you require the help from the software development engineers, right? Because they are very good in these things. Right? Okay. Anyway, guys, let's talk about the practical, right? I'm showing you the notebook because again, we don't have a time to type everything, right? So don't think again. Definitely, guys, we'll take few more sessions, right? That's for sure, right? Where we'll implement the rack from end to end, right? So just to give the time, guys, because I cannot deliver. I'm telling that I have not delivered the entire content, right, with you, right? Hi guys, we'll share the documents and we'll share the files with you. Don't worry. Everything we are going to share with you. Okay, fine. So let's do one thing, guys. Could you please do with me so that I can explain you each syntax and how exactly the things are happening, right? Please let me know because I have a class at 10 o'clock, guys. So please. Okay. So let's guys first install this packages, right, that you are having here, right? Just to launch the Jupyter, you launch the your Google Colab and just run these things, load these packages, right? Right. Just do it fast, guys, and run it. Right? Okay, just launch it, guys. Okay. Let me tell you guys what exactly we are doing in this. These are the some packages that we are going to install first, right? So I already talk about the LangChain, right? You are having a first thing which is a LangChain underscore community, right? So usually, guys, we are using here vector databases now, right? We are using vector databases, correct? Particularly in this thing I'm talking about, right? So we required some packages, right? That maintain the integration with the different kinds of a databases, right? So what it is providing you guys, I'm installing this LangChain community package. This package will contains, you can say that this package will contain, this package will contains the community integration, right? You can say that community integration. Community integration means what? Definitely, guys, you are integrating with the different kinds of a vector databases such as ChromaDB, right? Uh, FAS, right? Many databases. You require the integration with the vector database. That's why we require this LangChain community package, right? Definitely, next thing that you are having a LangChain OpenAI, right? So this package will allow you to communicate with the OpenAI model, right? So let's this one we are using to communicate so that your LangChain, right? So it is allowing you the LangChains to communicate with the OpenAI packages, OpenAI models. Okay. Then you are having a LangChain text underscore splitter, right? So it is containing some sort of a text splitting utilities, right? It will contain some sort of the text splitting utilities that we required here. Correct. If you talk about this second one, you are having a fast CPU. I'm using this one, right? Facebook AI search library to store your embedding vectors here, right? I required one more library kind of thing, which is a PyPDF because I'm passing here PDF, right? So we required some sort of a library which reads your PDF document, correct? This is the OpenAI, right? OpenAI tick token, right? This we are using just for the tokenization, right? I hope guys you are aware of something about the tokenization, this kind of a thing, right? Okay. And then the second thing we are having a sentence transformer, right? This is the kind of a pre-trained embedding model that we are using here, guys, right? Okay. And PyPDF is a kind of a library that we are using particularly to read a PDF. Correct. I hope guys this part is clear that we are doing an installation of this one. Right. Now the second thing that we need to do, you need to upload a file. Run this command guys to upload the files. And you upload any PDF which you have, right? Not specific to my PDF. You upload your any PDF that you have. Right. So let me explain the flow that what exactly we are trying to do here. Right. Let me explain what is your flow. After learning this one, you upload your PDF guys here. Right. Let me know guys. Fatafat do it and let me know once you are done with this. Fine. Anyway, okay. So let's take guys what is our flow that what we are trying to do in this case. Right. Usually guys, let's take I am having a one PDF. I'm having a one PDF. Right. So I have installed a library called PyPDF, right? PyPDF, right? What does PyPDF will do? PyPDF will read your PDF and extract the text from the PDF, right? So PyPDF will extract the text from your PDF. Then you are having a text splitter that we have installed, if you see, right? So usually, guys, you are splitting the text to form a chunks, right? So you are having a chunks. Correct. We'll later see what are the different kinds of a chunking we are using, right? And then we are having this sentence transformer, right? Which is converting this into the embedding vectors, right? So this is the sentence transformer, which is converting this into the embedding vectors. Correct. Once it is getting converted into the embedding vector, guys, we have used this fast CPU now, Facebook AI similarity search, right? This one, right? It is providing you the vector database. And to integrate with this only, we have used the LangChain community package, guys, right? Vector databases, right? Now this everything, this embedding vector is available in your vector databases. Correct? I hope guys you understand the flow. I have a PDF. My PDF is reading the text, extract the text, splitter is splitting the text, converting into the chunks. Then I'm giving that to the sentence transformer. Sentence transformer is converting into the embedding vectors, and we are having another package which is a fast CPU. It is providing you the vector databases kind of a thing, or we can say that it's a kind of a vector storage, right? Where you can retrieve a vector based on the similarity search, right? So I'm storing all the vectors in that one. Now what will happen? Once you store it in that case, user will ask the question. User will ask the question based on that PDF only, right? So once user asks the question, guys, definitely it should be converted into the vector now. Again, the sentence transformer will come here, right? Because it is responsible for converting your question into vector. So here the sentence transformer will come, right? Right. What it will do, sentence transformer, it is converting into the one kind of a question vector. Right? So entire thing is getting converted into the question vector. Now what will happen? Now you will do this similarity search on this. Right? You can do this kind of a similarity search on the basis of this. Correct? Once you do this kind of a similarity search, it will give you the relevant vector. Correct? Once you get a relevant vector, guys, right? You have a LangChain right now, because through LangChain only you can communicate with this LLM, right? Now what it will do? Definitely it will do the prompt creation, right? And once the prompt creation will be done, it is giving the answer. Right? So you don't want the answer in the vector format, na guys, that these are my relevant vector. So definitely it should be converted into the text, right? So this is the kind of thing I wanted to implement, guys, right? I'm focusing on this thing. So we will try to implement this simple use case only, right? So same thing I have done here, guys, in this case, right? If you go into this code, I have loaded and I have installed this py-pdf4 library. Don't worry, guys. I will share this thing with you, right? So it is reading the entire text, right? And it is also extracting the text here, right? So that is the first step now, that py-pdf is reading the text and also extracting the text from the PDF. Now there will be the role of a text splitter, that we need to convert this text into a chunks. So see guys, here it is converting that text into the chunks, and here I am using what? Here I am using the recursive character text splitter. So I am using here recursive kinds of a chunking, right? And the chunk size will be 800. Means what? What do you think, guys? What is 800? Means each chunks is having almost 800 characters, right? And what is chunk overlap? Means what, guys? Right? You can say that each chunks will repeat a 200 characters from the previous chunks. So you are having a total 800 characters in each chunks, and out of that 800, 200 character can be repeat from the previous chunks, because we want a relevant vector, guys, right? And we are doing here a chunking, right? This is the code for a chunking, right? That we are splitting the text into a chunks. Okay. Now, guys, second thing that you need to do embedding, right? So usually I'm using a external thing, which is the Hugging Face embedding right here. So as I told, that LangChain community has different kinds of integration. Not only we are using a vector databases, definitely we require a Hugging Face kind of integration, so that we can directly use the models from the Hugging Face, right? So anyway, guys, in your syllabus, you are having a complete Hugging Face where we are learning a fine tuning and all these things. Okay, fine. So here I am using this model, guys, which we call it as the embedding model, right? This embedding model I'm using to do a particular embedding here, right? So if you observe this flow, text splitter, now I am converting into the embedding vectors, right? Now, once you converted into the embedding vectors, guys, right? So what it will do? What is the next step, guys? Once you convert it into the embedding vector, right? So the next step will be obviously that embedding vector we have to store inside this FAST database, which is provided by the Facebook AI similarity search, right? So I'm storing this one, right? You are having this is the kind of a thing that you have created the object for this one, and you are having a chunks, and I'm passing the embedding vector to that one. Correct. Now, the last step will be once you are stored here, the user will ask the question, guys. So I have written a function here to ask the question here, right? So I have loaded a simple PDF of the LSTM here, right? And based on that, I'm asking a question. So suppose I'm asking a question, what is the LSTM? So what it is doing, guys, it is searching into the vector databases and it is giving me the answer. This is the kind of thing, right? So here, guys, I didn't use any kind of a LLM here, right? Even for the top relevant vector, guys. And see, guys, if you talk about the how security work, all these things, right? It will take a time, guys, है ना? Just to hold on, है ना? Just to focus on first this thing, then we'll talk about the security and compliance, privacy, and all this thing, right? Fine. Okay, fine. Because it will go beyond the basic sessions, guys, है ना? It will go to the advanced, right? So let it be. We'll keep simple only, right? Fine. Okay, but definitely for sure in the upcoming session we'll take that kind of a scenario based questions also, right? Fine, don't worry. I hope, guys, you got it. I will share this PDF with you, PDF as well as this notebook with you. You go through it because whatever I explained, same to same will be there, guys. And don't run behind the syntaxes, guys. Every 2 months, 3 months, there will be changes in the syntaxes, right? So don't worry, अगर आप भूल भी जाओ syntax तो कोई दिक्कत नहीं है. You will get everything, right? Clear, guys? I hope everyone understood. Okay. Hopefully, guys, we'll take one more session where we'll implement the end-to-end RAG and we'll use the LLM, right? We'll take any open, we'll take any LLM and we'll try to implement a RAG, right? Uh, I hope you want that kind of session, guys, right? Well, we'll get an end-to-end practical session which is related to the RAG, right? So we'll discuss this one. But guys, first go through it, है ना? We'll discuss, right? Anyway, guys, thank you for joining. Right, I have a class at 10 o'clock. Right, I will share everything. Don't worry. So we'll meet. We'll arrange one more session and we'll discuss about the remaining things. Fine, guys. Na? This is the very short explanation, guys. Again, I'm telling there is a too much to discuss into the RAG. There are various kinds of a scenario-based question. Many things. Right. Right. Yeah, surely we'll do, guys. Olama and RAG setup. Right. Okay, guys. Thank you so much. We'll meet tomorrow. We'll meet again. Bye bye.